Good morning, you all. Back to my session. In this session, I'd like to discuss with you what is principal component analysis and how so far you can use the factor analysis using SPSS for a data set or to a data file. What can you have with you? My stress is on these contents, please, and why factor analysis for ELT people, of course, scholars and teachers. What is PCA or FA? When we can use FA? What is the terminology which we can use in FA, that is factor analysis, and what are the underlying steps? What are the advantages? And how to do the factor analysis for a sample data file in SPSS? And I have put on my slide some of the SPSS data files. Yeah. Why factor analysis? Imagine you have a large number of measures or characteristics with you in your data set. For example, you have given a new questionnaire which is having 50 questions to some 100 people. Okay, then you have with you 5,000 scores, right? This is far too much for you to easily make sense of the information or to analyze the data, whatever you have with you, right? Here, the factor analysis allows you to reduce the mass of data to a smaller one, and you can easily manage the complete data set or your data. So it works a little bit like regression to find out the factors, and the factors are nothing but new measures or dimensions which summarize our data set, right? Yeah. Imagine your questionnaire asks one particular question 5 times in a different way. Of course, different ways. You would expect people to give much the same answer each and every time. So in other words, the scores from the 5 questions would be highly intercorrelated with each other, right? Of course, somebody responds if in a particular way to one of the questions. We know that they will respond the same way might be to others, right? So therefore, rather than the present the same information 5 times, it would be better to summarize the data, right? For example, you do this with a factor. If the question were, do you like dogs or pets, or dogs nice, another one is, do you hate pets or dogs, and so on. In this way, you may have 5 scores for this particular attributes. You could reduce the 5 scores that each person gives to one factor you call a dimension, okay, which will might call with one attribute or factor or you call dimension, that is dog attitude, right? In this dog attitude, all these 4 or 5 questions will come. Do you like dogs? Are dogs nice? Do you hate dogs? Dogs are barking, and so on, like. Okay? Yes. Once you have identified your factors or dimensions, you can describe the extent to which each question belongs to the factor. And it can be expressed as a loading, right? A factor loading is simply a correlation coefficient, which tells us the extent to which a question is measuring that particular factor. Now, these Do you like dogs? Are dogs nice? Do you hate dogs? All this comes under one and only one item of factor we call dimension, that is dog attitude, right? So now this is expressed as with the one loading. Of course, this loading is nothing but the correlation coefficient. Yeah. So in the above said example, you would expect do you like dogs to have a high positive loading on the dog attitude factor. You would expect do you hate the dog, of course, to have a high negative loading. This means what? You can have positive loadings, you can have negative loadings. Means positive correlation coefficient, negative correlation coefficient. Fine. A question such as do you like alcohol? Okay, let us suppose that a question such as do you like alcohol should have a loading of close to 0, because this is an irrelevant to dog attitudes, right? Similarly, the question about whether you like dogs would have a loading of close to 0 if we will consider a different factor such as drink preferences, right? So whether you like dogs, this won't come under drink preferences. Okay, this cannot load. Would have a loading of close to 0 if we were consider a different factor such as drink preferences. Hope you understood how you are having an item or variable and how it comes under a factor with this example. I would like to give some more examples here. Another example is age, gender, marital status, and so on. You can combine under one dimension. You call a factor, that is demographic characteristic, or you can take the demographic profile. Okay, if you can take the income level, education, employment status, if you can combine under some other factor, that factor you call as socio-economic status, right? So other one is assistance and support. You can take trustworthy, of course leadership and communication combined under some other factor or variable, that is you call as management style. Fine. Once if you can have identify your factors, you can mimic or you can describe the extent to which each question belongs to the factor, and it can be expressed as a loading. It is also nothing but simply your correlation. Fine. Now, how you can give a little introduction on principal component analysis and what is the factor analysis, what is the criteria. Simply, this PCA is used for the identification of smaller number of factors from the given set of large variables in the study. This means PCA is a dimensional reduction method. If you can have large variables, it can be converted into very smaller variables to analyze your data. In that way, you can easily give the interpretation about your dimensional data set by reducing the smaller or low dimensional data sets. To apply the principal component analysis, there are three minimum criteria it can follow. Okay, the first one is you should concentrate on the sample size. The suggested sample size is minimum for factor analysis by Jones 2007. The second criteria is these items should have the inter-item correlation, to look at the correlation between the items. and it should be in the range of 0.3 and 0.8. Okay, so here we conduct the factor analysis for all the items, whatever the items you can have in your data set, and consider the correlations which are greater than 0.8 and below 0.3 you can draw from your analysis. This is by Phil 2009. Finally, the third one is the sampling adequacy. Of course, the sampling adequacy can also play a vital and significant role. Okay, so where it comes from the KMO, that is Kaiser-Meyer-Alkin measure. Okay, this will give you whether your sample is adequate or not. Yeah, the values for KMO measure range is from 0 to 1. Of course, values which are very closer to 1 are the most appropriate, and the values which are less than 0.5 are unacceptable. This is about one criteria which we can have in factor analysis before going to do the factor analysis, right? Yeah. So another one is Bartlett's test of sphericity. So this will give you an idea about the correlation matrix. The correlation matrix is an identity matrix among the variables or not. This is by Parsian 2009. So for interpreting the study, apply for factor rotation to principal component analysis, we can use Varimax orthogonal rotation approach, right? This will give you the complete idea how you can extract your factors from the high dimensional data set to low or smaller dimensional factors to your data set. Here to achieve higher accuracy and precision, we can draw the dimensions which are below 0.5, right? Here the eigenvalues and the screen plots were considered to identify the factors to be retained. So studies earlier recommended to adopt all the factors with the eigenvalue should be greater than or equal to 1 by Field 2009. Yeah. So how you do the factor analysis or exploratory factor analysis? Of course, the exploratory factor analysis will cover all the characteristics of the data which we can extract. Fine. So factor analysis is used to analyze the interrelationship among a large number of variables and to explain these variables in terms of their common underlying factors. That is an idea. So the factor analysis was applied in the study for identification of the core factors, right? So number of variables attributed with one dimension or a single factor. So that is core factor you call. Here we would like to use the factor analysis for a personality test what I have taken from the behavioral study. Okay, this technique was considered appropriate as it requires no pre-existing functional relationships, and it is known as for uh, it is well known for us as simply data reduction. It is used to reduce simply large number of variables into a few number of core factors we call as dimensions, right? Now you can mimic your data with these factors or dimensions. Here I have taken the responses from the questionnaire which are connected to the personality of individuals. Okay, this is my personality.sav is my data set to discuss or to analyze the factor analysis per PCA. Right. Now this is the terminology which we can use in the factor analysis. Right. First one, you should concentrate on eigenvalues. It's a measure it's a measure to know the variance in all the variables corresponding to each and every factor. Okay, so this means what? Eigenvalue will give how so far the variance is extracted from the data set generally. So factors with eigenvalues we should consider more than 0, more than 1.0. And commonalities, the commonalities will give you the, of course, measure the percentage of variance, how a variable can be explained by the factors extracted, and the range is 0 to 1. So usually we will prefer more than 0.5. Okay, and its range is from 0 to 1. A high commonality value indicates the maximum amount of the variable in the variable is explained by the factors extracted from the factor analysis. Fine. This is about the commonalities, right? Yes. Now the total variance explained. Yes. This is an intermediate step in factor analysis, how you can explain the total variance in terms of percentage of variance of the variables explained. Okay, this calculate by adding all the commonality values of each variable, which dividing by the number of variables. That is, the total variance explained in terms of percentage for each variable. Next, factor variance explained. Yeah, the factor variance explained is the percentage of your total variance of the variables explained by the factors. Okay, so you can calculate this by adding the squared factor loadings of all the variables and divide it by the number of variables. Please, just you should remember the total variance explained is the percentage of total variance of the variable explained in factor analysis, and factor variance explained is the factor variance explained is the percentage of the total variance of the variable explained by the factors. Okay, yeah, yes. Now here, in order to use the factor analysis for the analysis, when you do analysis, you have to decide how many factors your data set or data contain. Okay, so there are usually two criteria. Okay, one is eigenvalue, just now I have explained, and another one is the scriptlet. These two will give you how many number of factors you are extracting for your data. Okay, so it is done with SPSS. Okay, so how you go to into SPSS editor, how you can analyze, how you can reduce your data with the factor analysis, I will explain. Okay, so by doing the analysis, you do not forget to request a scriptlet and to test the rotation varimax, that is the method which we can follow. Okay, we can follow the varimax rotation approach. Okay, even if you want to produce the factor scores, just you can select save as variable option and leave the method on regression. This is just like an extension of your factor, how you can get the regression scores. Okay, yes. So in the end, your choice of how many factors you are extracting from your data will involve the judgment and as well naming your factors, of course, right? And you can interpret your data with these factors. Okay, so these are underlying steps to use the factor analysis, what I have explained one by one just now. Okay, so what are the advantages with the help of this PCA factor analysis for your a data set which is having a large variables? Okay, yeah. Now, I have put on my slide some of the SPSS data files which I have extracted from the web. Okay, yeah. Now I go to the factor analysis, right? Yes, I am opening my SPSS editor to analyze the data by using the factor analysis. Okay, yeah. Here in your data set, you can have 44 questions on personality test. Here I am opening my data set in SPSS which was already stored in my SPSS editor. Okay, go to that file, uh, which was stored in my SPSS editor, that is about personality test. Just a minute, please. Yeah, this is the data set. Okay, yes, this is the data set. This data set consists of 44 questions. Okay, so my variable name pers01. This is the first one is I am talkative, and the second one is I seemed to be find fault, and third one is I do a thorough job. These all are the variables which are connected to personality of you. Okay, so that is your personality concern your 44 questions. But which variable is more important, which variable will give you the complete idea about your personality. Okay, so all these attributed to some number of factors, right? We cannot use all 44 questions or 44 items to analyze your data. This means what? Some variables comes under one factor, some other variables comes under the second factor, like that. We need to identify what are those factors with these 44 variables. Now what I'm doing, I'm going to toolbar, top menu, item is analyze, and go to dimensional reduction, go to factor analysis. Okay, so click on that factor. Yes, now factor analysis dialog box or a pop-up menu has been displayed. Now in variable list you can have all 44 variables. Now we will take all these 44 variables for our study. So now your variable box is now empty. Now what I'm doing, I'm clicking on this 44. Then now this you enter with the study variables, right? Yeah. Now for this data set for the study variables, how can you mimic your data with the factor analysis? First of all, my concentration is on descriptives. You compute the descriptives, that is univariate descriptives like mean, standard deviation, and so on. Right. Then you can go for testing the adequacy of the sample. Okay, so adequacy of the sample is by KMO analysis, KMO tool, and another one is a batless test for specificity of your sample, to know the specificity of a sample. So that is that will give you an idea about the correlation matrix. Okay, you can take the correlation coefficient and their significant levels. Okay, now, so before going to do all the factor analysis, you should remember one thing. For your sample data set, first of all, just you can check the reliability and the validity, right? So you can take your questionnaire, okay, and you can do the pilot study. After pilot study, just you test the reliability. It is easy to test the reliability of the data by using the reliability test. Okay, so usually reliability gives us consistency or stability of the data. Okay, so here usually the reliability test, that alpha, Cram-Batch alpha, we can agree, we can accept if it is uh, uh, more than the 50%. Okay, it is acceptable, and you can test the validity of the data. What is this validation or validity? Validity will give you an idea about the accuracy or degree of accuracy about your data, right? So you can take the help of if you're doing your research or if you are collecting the data for your research, or of course for writing a article, after pilot study, uh, you can test the validity of your data by taking the help of suggestions or help from the research supervisor, or you can take help from the subject experts. For example, here the subject is the personality test. This comes under psychological statistics, right? So you can take the help of psychological study experts. In that way, it is easy to test the validity and reliability of your data. Then you go for the analysis, right? Now, what I would like to do here at this stage, I'm continuing. Yeah, fine. Then extraction method. You go to this option. What is this extraction? Yeah, you're doing the extraction, factor extraction with which method? That is principal component analysis. So that's why here it already default here you can have principal components. Fine. Yeah, just you keep as it is. Yeah, the study is you're extracting this factor analysis with eigenvalues, no? That is based on eigenvalues. So based on eigenvalues, the value is that is one default value is 1. Okay, now the maximum iterations for the factor analysis default it takes 25, means the maximum iterations for converging is 25 in factor analysis, right? Yeah. Then now come to rotation. What is this rotation? Yes, the rotation matrix will give you about the factor analysis. How many number of factors which we can extract, right? So you can choose now that is Varimax rotation solution. Right? Here it displays the rotated solutions with the help of this Varimax. Now continue. Okay. Then scores. Now here display the factor scores coefficient matrix. If you want to display the factor score coefficient matrix, it will display the factor score coefficient matrix, right? Yeah. Then if you want to save as a variable with regression, then you go and choose the regression. I mean, the factors in terms of regression will be displayed in your uh, factor analysis data set, and of course data file. Okay, if you want to do that, you can. Then this display the factor score coefficient matrix. That is about scores. Then continue. The last one is options. What is this options? Yeah, here if you can have the missing values, exclude cases list-wise, exclude cases pair-wise, replace with mean, like that you can have. Just which was already highlighted with exclude cases list-wise, just you keep as it is, right? Then coefficient display format, sorted by size or suppress small coefficients. Yeah, each value we will take here, suppress the small coefficients. That is 0.1 is here. I am taking here is 0.3 or 0.5. Okay. So if you can take 0.5, it display 0.5 and above. If you can take here 0.3, it gives you from 0.3 to the high value, that is up to 1. Okay, now so here I am taking 0.5. Okay, of course even you can take the 0.4. Okay, usually we prefer 0.5 or above 0.3, my sure. Then continue, right? Now you can say okay. Now you can see, yeah, in your output view, in output window, the complete factor analysis results has been displayed. First one is descriptive statistics. We can have 44 variables now. Yes. For each and every variable, it will display the mean score and standard deviation score. Here you can see the mean score. First variable is I am talkative. The mean score is 3.62. The mean score is 3.62. Actually, what is this 3.62? 3.62 is the score about your variable label value. Actually, what is that? Just I'm going back. You can see this is my variable view. Sorry, data view. This is variable view now. Now you can see. Now you can see. Uh, Yeah, I am talkative. How many? What are the values you can have for a scale? One is strongly disagree, two is disagree, three is unsure. Yeah. Now, what the question is, I am talkative. The mean score for this I am talkative is 3 point something. 3 point something. That comes under unsure. Okay. Now I am going back to here. You can see 3.62. Almost it is, of course, nearby 4. 3.62. So this is now 4 in this sense. What is 4? 4 is agree. So he is they are agreeing. They are agreeing with the variable is I am active like. Okay, no? So in this way you give the discussion in that way. I am talkative. So the mean score is 3.62. Of course, it is nearby 4. So many of the most of them are agreeing with I am talkative. Okay, so that is 433 members. Okay, this is about descriptive statistics. These are the correlations. 44 for 44 variables, the correlations has been displayed here, right? And whether these correlations are significant or not, that is displayed in this table. I am talkative. I am talkative. One variable. This is correlated with many variables. So see that is significant with third variable, third item is significant with the fourth item. What are these third and fourth items? Just you can see third and fourth items. Yeah, I do a thorough job. You are talkative and it is connected with I do a thorough job. You can have significant relation. Similarly, I am depressed. You can have some significant relation. So like that you can easily explain the correlation. But our interest is not this. Just you should take. Now KM1 and the backlash test. Yeah. Whether your sample is adequate or not. Just you can check before going to do the complete factor analysis in order to discuss the results and everything. See, here Kaiser-Meyer Alkan measure, that is KMO. So whether your sample is adequate or not, just you can see 0.841. Wow, it's so nice. So now it is highly acceptable because it crossed 0.5 now. So it is 0.84 in this sense. So it is highly accepted. Your sample data is adequate now. Next one is the backlash test for sphericity. So this will give you an idea about uh, whether your test is okay or not. So now here by using best fit or not like that. So here it is giving this highly significant because the value is p less than 0.05. This is backlash test for specificity. Usually it will give you an idea about the correlation matrix which is significant or not. So that is significant. And the correlation matrix is appearing as an identity matrix. All the principal diagonal elements are equal to 1 or not. Okay, that is okay. Now comes to the communality. Yes, here the communality is also an intermediate step in analyzing, extracting the factors in factor analysis. I am targeted. The initial iteration is in default, this is 1, and after extracting, it is covering 0.749. That is, it is covering 74.9 percentage of variance in extracting the factor. Okay, similarly, I seemed to be find the fault. It is covering the 56.4%, 56.4 percentage of variance. It is explaining about the factors. Okay, yeah. Now here extraction method what you have used, that is principal component analysis. Now here how the total variance explained for each and every component by taking the eigenvalues, extraction and sum of square loadings and rotation sum of the square loadings. Just you should concentrate how many number of components or factors extracted, just you can see. It depends upon the eigenvalue. Eigenvalues are now above 1 are preferable, right? The first component is high eigenvalue is 7.280. This is very high. Okay, this is the first the component or factor which is more than one, and it is highly explained the total percentage of variance. The first one, it is explained, the first factor or first component explained 16.54 percentage of variance. This is very high. Okay, so the first factor is a first priority factor. It is explaining more percentage of variance. Then comes to the second one, second component, that is 4.192. The eigenvalue is 4.192. This is uh, more than one, of course. This will give you the second importance in dimensional reduction. This will cover, explains that 9.52 percentage of variance. Okay, the next column is about the cumulative variance. So here the total variance explained by these four components by concentrating on the eigenvalues which are above. The least component, the least factor uh, eigenvalue is 1.04 for something. This is explains a very less percentage of variance, that is 2.373. In that way, you can explain the total variance, which gives an idea about the factor, each and every factor in factor analysis. Yes. Now this is the component matrix. The component matrix is having, of course, 10 components. Of course, 10. You treat 10 factors, right? Yeah. For each and every factor, what are the variables? The first factor. What is the variable? Variable is I am talkative, because this is 0.55. This exceeds 0.5. And third one, that is I do a thorough job. That is of course 0.51. And then fourth one, I am depressed. That is minus 0.516. Of course, here for each and every variable, the factor loading. These are the factor loadings are correlations. You know very well, the factor loadings are loadings gives us about the correlation coefficients. May your variable loaded with a positive loading or a negative loading. Okay, so in that way, for each and every factor, how many number of variables you can combine, that I have given in each column, right? So here in first factor, how many number of variables? First variable, no question of second variable, then third, fourth, fifth, no question of third variable, which is combined with the first factor. Likewise, just you can check for all 44. Okay, if you can sort, it will give you uh, uh, the variables in a systematic manner, and the second factor, third factor, fourth factor, and so on. This is component matrix, right? So of course this component matrix rotated uh, with the rotated component matrix. Okay, so there is no change in analysis, but how many number of times the component matrix rotated, that will be displayed here. Okay, so in that way you can see the first component, I do a thorough job. That is now it is covering, it is explaining the correlation value. The first factor loading is 0.697. Okay, and second variable, that is I am careless. The first one is I do a thorough job, and the eighth one is I am careless. That is having the negative loading. Okay, that is negative correlation. So in this way, the rotated component matrix will give you again all 10 idea about all 10 factors. Okay, for each factor, what are the variables combined, that is displaying here. Okay, so in that way, you will get an idea with the extraction method, the principal component analysis, the rotation method, that is varimax with the Kaiser normalization, right? So this is the method, please. Okay, here the component transformation matrix will be displayed with 10 components with the cross tabulation. Okay, now, yeah. Now component coefficient score matrix also will be displayed. Now I am talkative. Uh, I seem to be fine default. all the component score coefficient matrix will be displayed here. Okay, now so these are also again, of course, the relations, right? Yeah. This is now component score covariance matrix. Of course, here you can see this is nothing but an identity matrix with the correlations, right? Yeah, the principal diagonal elements are equal to 1. So now this is done with uh, your matrix sphericity test. Of course, the correlation coefficient matrix is now an identity matrix, right? I'm coming back, and what are the factors now? What are the uh, one variable values includes in this particular factor? This you can take and you can analyze. Just I'm going back uh, uh, to factor analysis, and just I do sorted by size. Then just you can click. Okay. Then you can say okay. Now see. Yes. See. Yeah. Rotated component matrix. How many factors you can have now? The number of factors, right? So now come to rotated component matrix. What are the number of how many number of factors you are extracted? 10 factors out of 44 variables, right? Now, in one first factor, how many variables comes under this factor? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 variables has come under one factor. These all 9 variables are attributed as one core factor in factor analysis. That is the beauty of uh, factor analysis in order to extract the factors for the data, right? So now the second factor includes I am quiet, I reserved, I am shy, I am talkative, I am outgoing. These comes under now the second factor. It could be attributed as one factor. Of course, you give the label name also. Okay, so I am quiet, I reserved, I am shy, I am talkative, I am outgoing. It can be attributed as like attitude of a person. In that way, we give the factor is like attitude. So in this way, you can give the factor names also, right? And you can analyze the data. So now, what is the top priority one? Top priority factor. First factor is the top priority. You can analyze. I am disorganized. So this is negatively correlated. I do a thorough job. That is 0.697. That is the correlation. Okay, in that way you can analyze the whole data. And second factor, this is includes these many variables. Okay, like attitude. Then this, then third one, then fourth one, then fifth one, then sixth one, then seventh, and so on. Likewise, you can take the rotated component matrix and you can analyze your data. Okay, so these are the core factors obtained for all those 44 variables with 10 components or 10 factors, right? Now the entire personality test data has only 10 factors out of 44 variables. This is the way of analyzing the factor analysis for your personality test. In that way, you can easily extract the results, and you can put all these results in all the results in Word document, and you can uh, give the description, and you can discuss the analysis how so far the 10 factors are influenced, right? Here just you can have I'm going to just you can have in rotation in scores. Yeah, this is okay, fine. Extraction, you can have here the scriptlet, right? Just you can click that on scriptlet. Just I'm going back and you can say okay. Now here uh, in factor analysis, as an intermediate step, you can have the scriptlet also. One second, it is, I think it is in process. It will display the screenshot. It takes some time. Yeah, processing. Yes, this is the script plot about your factors, 10 components. C. Now, along with x-axis, you can have the component number or factor. Along with the y-axis, you can have the eigenvalue. Okay, the top eigenvalue is for first factor. This is very high. Okay, this is a significant factor to describe about your data. This the next significant is the second one is the second factor, then third, fourth, and so on. The values which are uh, greater than one we can take now. So up to 10 factors we can take 1, 2, 3, and so on up to 10. Okay, so this is a highly influence factor. This is the next influence factor. This is the next, and so on. This is the way to describe the script plot in the factor analysis, right? So this is the advantage. Now, already I have explained what are the component matrix dimensions here, how you'll be getting all these rotated from the rotated component matrix, how each factor includes the number of variables and so on. Okay, so this is about the factor analysis. Okay, so here you can have 44 variables, that is high dimensional data. We have converted into very uh, minimum number of dimensions or factors using the factor analysis. This approach is known as the principal component analysis or factor analysis. This is nothing but a dimensional reduction approach. Thank you all for giving me this opportunity, and I'm very much thankful to you for listening patiently this long session. Now this is the time for the quiz. Okay, if you can have any Q and A's, please you post in the chat box. Even Q and A's, I have put on link with the 60 or 70 questions with my explanations. Right? Even I have put 20 to 30 questions on factor analysis, how to do, how you can analyze the factor analysis, how you can reduce the high dimensions to very few number of dimensions for your data set that I had explained with my Q and yes, just you go to my link. Okay, now you can take the quiz for 10 minutes. I very much thankful to you everyone for listening patiently all my long session lectures, day 1 and day 2. And also, I very much thankful to you, uh, Head Department of English, Prabhavati ma'am, and conveners, uh, Madhavi ma'am, Dr. Madhavi ma'am, and Dr. Subhashis for giving me this good opportunity to share my views with data analysis using SPSS with you all. Okay, at outside, I would like to say thank to my better half and my son who helped me in preparing the quiz, in preparing the documentation for these long sessions. Thank you, everyone. Thanks a lot. I wish you all the best.